So welcome everyone, and today we're going to go ahead and we're going to talk about Oracle RAC and Active Data Guard, and we're going to talk about how it aligns with Oracle's Converged Database solution. Just to introduce myself, my name is Glen Hawkins. I'm the Senior Director of Product Management for Oracle Maximum Availability Architecture, which is all the different HA and DR technologies, which hopefully a lot of you are familiar with. As well as Data Guard, Flashback, and a bunch of other technologies. And with me today is Anil Nair, our very own Oracle RAC and ASM product manager. So we'll be going ahead and jumping into these. And to start with, I want to go ahead and start with what basically we're going ahead and talking about as far as a converged database. Well, what does it mean? I mean, it's not something it's not a product that Oracle sells. It's actually part of our overall strategy and has been for some time. And if we go ahead and kind of look where it's coming from, from a converged database standpoint, where the solution is trying to address, it's important to go ahead and take a step back and look at what's been going on the Oracle, or just the database landscape in general, and why single-purpose database has evolved. So single-purpose databases evolve with different data types, different type of workloads to address things like spatial, text searching, reporting, graphical, JSON, lots of different workloads, lots of different data types supported. And so these single-purpose databases specialized in these different areas and made it very easy for developers to pick up the technology. However, it also introduced some additional complexity because a lot of times the application starts with maybe one or two or maybe three of these single-purpose databases to one application. And then a lot of times it can evolve and we get additional, as an application gets more requirements and tends to be enhanced, you might get more reporting in there. You may get graphical data, more machine learning for analytical purposes. And so your application can grow to include maybe 5 or 6 single-purpose databases. Each one of these fragments in the data and making it very difficult to do any type of joining, any type of integration across these. It also locks you in from a single purpose as far as administration, maintenance, and everything that goes along with that. These apps require specialized knowledge, and these data movement, or maybe ETL or data integration technologies, are routinely utilized to go ahead and tie the data together. Going ahead and creating more data integration components that also need to be set up in high availability, also need to be maintained, also need to be patched, and also need to be configured. So you're introducing more and more specialized skills and unique management. And while these single-purpose databases are excellent at doing what they do for a specific data type, a lot of times they have very different paradigms associated with them from a security, high availability. Basically, the entire infrastructure is routinely different. Patching, the life cycle is often different. So you have completely different security, high availability, disaster recovery, and the latter two are what we're focusing on in this particular session. So if we look at it from that perspective, we have all our different silos associated with the relational, with our graph data, our JSON data, and in order to go ahead and set up our, let's say, a disaster recovery site for these technologies, you have to take each one of these silos using the paradigm, the infrastructure that's specialized to go ahead and support that particular data type, usually with skills and administrators on your team that have to go ahead and become specialists to go ahead and create these disaster recovery sites. So you get a whole bunch of different silos. You also have to go ahead and, of course, within your disaster recovery plan, handle all the data integration for these different data types to go ahead and tie it together, which can be complex as well. The end result is you're juggling, just like our juggler in our photo here, is to go ahead and configure and manage these things to adapt to partial failures. What if just one of these single-purpose databases fail? How will it impact our application? Can the application still run? All these type of things need to be considered as you go ahead and set up these environments. So in a nutshell, the converged database goes ahead and solves this problem by handling all these different data types, all these different type of workloads, and within the Oracle database. It's all tied together, no more fragmentation associated with it. You set up your disaster recovery, you can easily go ahead and just set it up using the Oracle database, normal DR, which we'll talk about here a little bit later. And all these different data types are no longer fragmented from being able to go ahead and join and utilizing them and connect them and integrate them together. They're all available to you. And your skills within your team, you no longer have to go ahead and fragment the skills across your team to become special in each one of these single-purpose databases. Rather, they can focus on the application, evolving it, and building the best, most optimized application infrastructure possible. So what makes the Oracle database so perfect for the use from a converged database standpoint? It has to do with all the layers that we've put on the Oracle database, and we're just focusing on 19C here, 21C being the latest. But 19C was our last terminal release, and a lot of you are probably running it. If you're not, this is the time to go ahead and upgrade to it. And all the layers that we put on there from a security standpoint, performance, scalability, our multi-tenant capability, manageability, and high available and app continuity are critical to this. And you're going, well, but what about the isolation? If I'm losing the isolation to go ahead and have my database and my schemas separate in each one of these different data types, because my schemas can be quite different associated with this. Well, we have a multi-tenant, and one of the reasons we mentioned multi-tenant, it's not only from a high availability standpoint, and there's a lot of advantages to multi-tenant from that perspective, from planned maintenance, as well as going ahead and setting up high availability for your database infrastructure and consolidation, but it also maintains that isolation and that portability. So all the advantages of the single purpose database are still present in the Oracle database with the capability to have a multi-tenant infrastructure, which is default in 21C and onwards. You will always have at least one PDB present within a container database. So all these different layers are there. They're all available to us. They're built into the database. They're not deployed separately. And all those data types that we talked about are supported here, as well as all the different workloads associated with them. So we have our spatial, we have our graph, we have our JSON. And you've heard many different announcements associated with the blockchain as well. And I'll share we even backported that functionality back to 19C. And all the different workload types from data science, transaction, Internet of Things, app development, all the machine learning that you might require in your environments, which is very popular nowadays, particularly in SaaS applications, for example, are all supported here within the infrastructure. And along with that, all the different capabilities that are associated with these data types, all these use cases, whether it be tamper-resistant blockchain or Internet of Things from a streaming data so you can do real-time analytics, are all there as well. So all the workloads, all the data types, and all the use cases that these single-purpose databases were designed for are addressed in the Oracle database with converged database capability that has all the layers and so you have security, you have high availability, they don't differ from one another, and they can all be configured at once. So when you set up your disaster recovery site, you set it up once for the Oracle database, and now you've gone ahead and covered all your different use cases. And it's very easy to go ahead and expand things out. We'll be talking about high availability as well as the scalability capabilities here in a moment. So this brings us back to what does the converged database do specifically for high availability and disaster recovery. So all these capabilities are there, all the different data types are available to us, and now we're going to go ahead specifically into how we address scalability and local HA and disaster recovery without making any changes to the application. And that's a critical part of what we provide here associated with it, specifically with some of the capabilities at the app tier and how clients connect up to the database. So first we'll be talking about RAC and how it ties in with scale out and local HA. And for that, I will hand it over to our expert, Anil Nair, to go ahead and cover RAC.
Thank you so much, Glenn. Great. So when we start talking about having all these different use cases into one converged database, we want to make sure that they are available and the database is available, and also there should be ways by which the sessions itself can benefit from these features. So let's start with the session level. So definitely one of the most common requirement of any application is that, hey, I have a lot of sessions and I want to be able to benefit from, let's say, the load balancing capabilities. Well, the Oracle client already has all the benefits like failover and load balancing, especially when you're using RAC. Now let's talk about the specific load balance aspect. Like typically you would see the other databases provide simple round robin capabilities. With Oracle, when you use services, especially with RAC, you can configure that either as a connection-based load balancing or runtime-based load balancing, where if a specific node is having enough CPU power, even though it is running a lot more number of application sessions, it can still be redirected because based on the runtime at that time, that node is most best to handle that incoming connection. Now, this is not something you would get with other databases. And also remember that this is by default. So all you have to do is go to servctl and say, hey, I want to use load balancing for my service, and boom, all your applications without any changes to their connect string or any of that sort be able to benefit from this feature. Additionally, along with that, you would have this second thing, which is called as the single client access network. So anytime you add or delete nodes, you don't have to worry about changing any of your sessions. And at the same time, if there's a failure or load information or other type of very interesting events, we make sure that these kind of information is propagated up to the connection pool. That makes it very easy for the application to benefit from it. Glenn, next slide, please. There we go. So if you have talked to your customer, if you have looked at Oracle RAC in the previous releases, and you would think that, hey, you know what, my application is so badly written or something that it is not able to benefit from RAC because it is having some of the things that we recommend you don't do for scalability purposes, then you should really look at real application clusters again, because we have tried to make, even though you've written code that is not very efficient, we will try to make sure that we can scale your database application. So in this case, I was talking to a customer recently who had, previously said, no, I don't think RAC can do it. Well, now with 19C, this is a quote that he has provided, which is basically that, if you have not looked into the new generation Oracle RAC 19C yet, you have not experienced what RAC can do for you. And if you want to look at the features and some of the details, I have provided the supporting collateral, and feel free to reach out to me if you have questions on that. Glenn, next slide, please. So you'd be very curious to know, hey, how does Oracle, RAC, new generation Oracle RAC scale all these kinds of workloads? Next screen, please. So we do this because we have a very unique and innovative feature called Oracle RAC Cache Fusion. So those of you know, this has been about for 20 years around, that before Cache Fusion, if you needed to read some data, you would actually need to make sure that the data is written from the node where the changes have occurred and then read again from the other instance. This is before Cache Fusion. Now with Cache Fusion, what we have done is we have enabled that buffer-to-buffer transfer so that we can utilize the benefits of the private network. And you have to remember, the private network has improved over the years, right? Remember back in the day, 10 MB, 1 gig, 10 gigs. Now 100 gigs are very, very common. And also latencies have reduced so much so that our RAC Cache Fusion can benefit from these features. Glenn, you can just press the animation. Yeah, so now as you can see, please continue. One more time, Glenn. Yeah, so now as you can see that, we even take care of the fact that we measure that, hey, the private network performance and the time to read from the SSD. So we can actually optimize it. So suppose your private network is a little bit, having some latency issue. We know that the disk is able to do it much faster, because especially if you have, say, some SSDs or some really high performant, storage, then we can benefit from whatever path we can. So the idea is the customer doesn't need to know of this. We'll automatically handle it in the background. Next slide, please. There's a whole list of optimizations. I just chose a smaller subset. And I keep talking about this index split optimizations because this is something that helps with the bigger problem of right-growing index, customer application. A right-growing index is nothing but a typical application where you have a primary key defined on a number that starts from, say, 1 or 2, leading up to, say, thousands and millions. What would happen is, because of the way you insert data, sometimes it happens that your blocks are not of the same, the binary tree heights kind of change. So we take care of it in the background. So we have optimizations for it so that we can make sure that even though you are having different kinds of inserts going on, and these are not exactly what we call as good for right growing index workloads, we actually are able to tune this much better. And again, there's a whole laundry list of things that I've put there. I've talked about that in the past, but more important is that such applications also can now benefit from the 19C new generation Oracle RAC. When we talk about the private network, I already mentioned the private network by itself, the latencies have improved over the years, and it's going to continue to improve. We also, on our hand, have made some changes and optimizations to what we call as the inter-process communication. On generic system, we use the lightweight IPC, which is really improved handling of the OS resources like sockets and file descriptors. And obviously on Exadata, we can do much better because we use RDMA. Next slide, please, Glenn. There you go. So what is so good about Oracle RAC on Exadata? Well, remember, as I said, RAC performance is directly related to how fast or how quickly it can send and receive data from the private network. And remember that on Exadata, we use RDMA. RDMA is just the capability of reading or accessing the data from a remote computer, and with Exafusion, that is a special feature we have on Exadata, we do it without involving the host OS or CPU. So basically, the user land process can read this data, and therefore we can scale really, really faster than other implementations. This eliminates, for example, the server side processing, context switches, and all that. So we can really go as fast as possible. So the whole premise of why Oracle RAC really is the best performant on Exadata is because the private network is extremely fast, and also we can do all this processing without involving context switches and all that. Next slide, please. Right. So reason number one that I gave earlier was because of our cache fusion, which is very, very adaptive, and also about how we use our resources, right? The second reason I would give is for how we use the resources. The resources are like CPU, network, disk, RAM. Every program or every user land application has access to these things. How we optimize use of these resources help us get even better performance. And remember, it's not just optimized, we are adaptive. So what that means is we will adapt based on the changes. Next slide, please. So to understand what is this adaptation, let's understand what is the modern CPU architecture based on. Like if you were like me and have been in computers or computing technology for the last 20 years at least, or 25 recently, you would see that most of these CPUs talk about one CPU is actually one physical socket, as we call it in the newer nomenclature. Whereas lately, if you look at one CPU, you need to clarify whether it's a thread or if it's a core, because now CPUs have modern architectures where the operating system is able to run multiple threads, which could be running on different cores, and the cores have access to the L1 cache and all that. So essentially, modern operating system along with modern CPUs are designed to run multiple threads in parallel. And so what we do, next slide, please. So we do is we have optimized our processes for critical processes for priority. We have added more threading and other things, and the ability to dynamically spawn these processes when needed. So if you see that LMS, we have started not only number of processes, we have threaded LMSs, so that can be spawned on demand. We also adapt the process itself, like as if it's running in higher priority or the regular TS priority. All of these are monitored by this important thing we call it as a database reliability framework. So database reliability framework monitors the current load on the system, monitors the current usage of these resources inside the database, and we are able to optimize these priorities and spawning of new threads to make sure that your performance is as fast as possible. That's why I keep saying it continuously adapts based on incoming workload. Next slide, please. So database reliability framework, I've talked about it a lot. It is basically a lot of metrics that we collect, and so we use some action item on those metrics. Let's just take an example of a GCCR block congested metric. That metric typically means that there is a lot of work that the LMS has to do. And so therefore, what we can infer is there is a lot of work coming in, that the database is getting busier and LMS is trying really hard to keep up. So at that moment, what we don't want to do is do any kind of activity that can make the LMS be busier. So we'll kind of say we'll disable DRM or enable DRM based on these things. So that way we don't actually end up making the thing worse. So we try to adapt to the events by automatically doing this in the background. And if you're interested, as I said, to find out how this happened, you can select from that $GCR log metric and see what has happened in the past. Next slide, please, Glenn. So all of these features together has helped us significantly. As you can see, from 11G up to 19C, we are about 7x faster for reconfiguration. Now, what is the reconfiguration? Reconfiguration is when an instance that is running a workload, fails for some reason. Let's say the hardware below that has failed or something is a problem. So the time it takes for the rest of the database instances to reconfigure and proceed, that has reduced by 7x times. That's a significant jump when you consider 11G and 19C. And it's not only about the things that I said, there's also a lot of other contributing features. The small list, I put it there on the right-hand side. But the most important thing is, guys, if you're not on 19C, we are 19C with the latest RU, you would see a lot of improvements in performance. Next slide, please. But as I said, we continuously improve, but we also are making more and more features available in 21C. Some of them, may or may not be backported to 19, and I'll talk about them specifically. Next slide, please. So let's talk about some of the features of 21C. Now, I'm going to focus a bit on HA, because remember, in a converged database, you're going to have a lot of databases converged into the Oracle RAC. So you really want to make sure that, if an instance goes down, it might be hosting multiple, purpose-built databases, instances or services. So you want to make sure that if there is a planned downtime requirement, that you are actually taking or optimizing it as much as possible. Now, remember, planned outages is like, say you have a security patch that you need to apply on the host operating system. So that's a planned downtime. Obviously, you would do draining and all that for your services, so your applications don't even see those changes. Now, in this context, in 21C, what we have done is, if you look at the image that I have shown, we have some admins for each of our blocks. We used to refer to them as block masters. And the blocks itself are also on a node. Now, let's say you need to take node 3, that's the third node, down because you want to apply a patch to it. Glenn, if you could please play them in animation. There you go. So as you say, I want to take down that services on that node, we will automatically move the block admins to the other instances, which means the other instances can initiate whatever it has to do to make sure that all those blocks are either return to disk or roll back, because there might be committed changes and uncommitted changes. We take care of all of that in the background without you having to worry about it. But the advantage of this thing is that because of this movement before the actual instance goes down, we even further reduce the reconfiguration time. Next slide, please. Yeah. The other feature I want to talk about is cache fusion hardening. Again, remember in the past that if you request a block and the block is not in the state, or block has certain discrepancies that it did not work out, then in the instance usually would crash. Now imagine when you have a lot of applications in a converged database, you don't want it to crash for this. So what we have added is this feature called cache fusion hardening. Glenn, if you can play the animation. Right. So in this case, a block is on the node B, which is in the state that it did not expect it to. So what it does is, instead of crashing the whole instance, says, hey, can you send me this again? Maybe I can fix it on my own. And certain types of failure, we try to handle this on our own so that we don't take the instance down. Next slide, please. Yep. There you go. So when the block is not in the state is found, we kind of got it back again. Thanks. Next slide, please. Also, we understand customers want to quickly deploy, quickly get these things, Oracle RAC used. So we have now, introduced in 21C support for production. Now, when I say introduced, typically Oracle RAC on Docker was supported for test and dev environments before 21C. But in 21C, now we do support production. So you could actually benefit from the rapid deployment of Docker with Oracle RAC. Next slide, please. Also, we have done what we call as automatic PDB resource management. Now, remember, as I said, when you use a converged database, you would get multiple purpose-built databases as services or PDBs into a converged database. Now, with our new, what we call as PDB resource management feature, you can now automatically spread the load or make sure that certain PDBs or services are started on certain instances. You can do all of that. You configure once, and you're able to benefit from all of these in 21C with the automatic PDB resource management feature. Next slide, please. Now, importantly, now you would say, hey, Anil, I don't have like a single or one or two installations of RAC. I have this whole big list. Now, how do I manage it? It's very cumbersome for me to do install and patch and maintain all of that. Well, we have heard your requests for improving this, and we have had this feature called Oracle Fleet Patching and Provisioning, which has been around for some time. It used to be called RHP, but actually the name Fleet Patching and Provisioning really describes this product. Because remember, it's not just deployment. You could just do a deployment using some automation like Ansible or whatever. But what makes this very unique is two things that I actually like. One is that you can make sure that you create what we call as a gold image repository. So let's say you're a bank and you have decided that, or your DBA team has decided that everybody should be, if they're using 19, they should be using 19.11 with these 5 patches. You could actually make sure that every single new deployment is using that gold image that is specific to your environment. Not only that, you could also find out which of the environments are diverging from this, so that you can make sure that they are not running unpatched, or which might be causing you or affecting security. So this is something really good, and this is not just for RAC. By the way, you can manage single instance, RAC 1 node, and on different kinds of environments, including Exadata. So this is something really, really cool that I think allows you to manage your RAC deployments with fleet patching and provisioning. Thanks. I think this is my last slide. Thank you. Glen, please take it over.
Thanks, Anil. So with that, we'll be going ahead and switching gears into the other side, the other main piece of high availability, and that's disaster recovery, right? And how we can go ahead and protect in the case of a major outage at a site. Can we go ahead and protect your data and bring your application up, ideally without any impact to the actual application itself? So probably comes as a surprise to absolutely no one on this call that topic would be covered with Oracle Data Guard. And for those that are unfamiliar with it, Data Guard's primary job is to go ahead and handle replication between a primary and a secondary site. So this can be done by asynchronous and asynchronous replication, and I'll talk about the different modes that we have available to go ahead and provide you with flexibility depending on how far the sites are apart from one another and the latency between them. But in a nutshell, all the redo is being communicated from the primary site to the secondary sites, or secondary sites, because there could be more than one, and we recommend that depending on your level of protection that you're going ahead and looking for. All in memory. So everything's happening in memory, nothing's happening on disk. What that means is if someone accidentally deletes a file off your disk, it's not going to be replicated over your secondary site and corrupted. Everything is being validated very carefully from at a block level continuously as the replication occurs. So we'll talk about kind of active, passive, but with Data Guard specifically, it is active passive that we're focused on. The standbys over there, we're not going ahead and we're not reading over. They're essentially sitting idle. We'll talk about active Data Guard here in a moment. This is a very useful technology, not only from a DR standpoint, but you'll also find it as a core technology to a lot of the different migration solutions that we have, particularly for zero downtime. So our ZDM feature, for example, to go ahead and handle zero downtime migration to either the cloud or perhaps to Exadata, The integral piece of that is Oracle Data Guard under the covers to go ahead and provide that support. Lots of different demos, lots of different capabilities associated with that you can find on o.com, and I'll talk about that in a moment. But the question often comes up is you have Data Guard and we have Active Data Guard here at Oracle. Why do we recommend Oracle Active Data Guard for maximum availability architecture and for other different kind of paradigms associated with it? It ties in with a few kind of key features that we'll just call advanced disaster recovery, advanced data protection. A bunch of different features associated with Active Data Guard. Now, it's mostly known for, and the name implies, an active infrastructure, which means you can actually offload historically read-only workloads off to your standby, so they're not sitting there idle. You can take advantage of those resources. Also, scalability benefits and other benefits associated with that. We have some limitations on that associated with it only being read-only before, and once in a while, people want us to be able to do some occasional updates. I'll talk about how we're doing that in a moment, but that we introduced that feature in 19C, expanding this concept of an active. Now, is this bidirectional replication? Full bidirectional like we have with Golden Gate? No, it's not. It's not designed really to set up a multi-master environment. So you can offload read-only workloads with the occasional update. Maybe no more than 5 to 10% of the overall workload on the standbys should be essentially an update or an insert associated with it. And I'll talk about why when I talk about our DML redirect feature, which enables that capability. Now, that is what Active Data Guard is well known for. It's not why we recommend it for maximum availability architecture. That ties in with a few other features associated with it, provide the data protection. The automatic block repair feature in particular that protects you from any type of block corruption. This is something that happens very rarely. It doesn't happen very often in a database, but when it does, it can have a huge impact on the actual application that's running the database, and it can be very, very difficult to recover from. So automatic block repair, if a corrupted block is discovered in either the standby site or the primary site, or standby site, should I say, if you have multiple standbys, it can go ahead and copy that block over from the standby or from the primary, automatically fix it. All you'll get is a notification in the activity logs associated with that, and it'll continue to run as normal. So you get that extra level of advanced protection, but it's a very, very critical one that can have huge repercussions if this rare occurrence occurs. The other feature, which I'm going to talk about here in a bit more time, is application continuity, and it's protecting your in-flight transactions as well as the committed transactions that you're used to thinking of with Data Guard. This feature is also present in RAC, and I'll talk about it a little more depth here in a moment. I have a slide dedicated specifically to that. Now, a couple other features that we have here are zero data loss across any distance, the ability to go ahead. Then we have a far sync feature, and we have a bunch of other features associated with the standby. So you can go ahead and offload backups to the standby because it's an exact physical replicant. You can also go ahead and do something called DBMS rolling. So we can do rolling upgrades and minimize your downtime, because keep in mind, the high availability is not just about disasters. It's about maintenance. Planned maintenance activities happen a lot more often than a disaster. And so we accommodate both with both the RAC and the Active Data Guard technologies. So this, in a nutshell, is how they differ from one another. There's a couple other components that you definitely should have in your infrastructure from a best practice standpoint. The Data Guard broker is one of them that will make your life a lot easier. So it's a small command line interface. It also integrates our Oracle Enterprise Manager solution that allows you to deploy and configure your Data Guard instances or your Data Guard against your database instances very easily. It can also deploy components like FarSync instances, and you can set up the observer for fast start failover. All these type of features are controlled with the Data Guard broker. I know not everybody out there is using it, but really this is a component you really want in your infrastructure. It's going to make your life easier. Now, the different Data Guard protection modes. Most people are familiar with those, but it's one of the real value adds that we have with Data Guard is having this level of flexibility. It all ties in with the fact that when you set up protection and you set up your sites, it may be in the next data center that's only 100 meters from the primary site, or it may be 1,000 miles apart. Depending upon the network latency, you may need to choose between synchronous replication and asynchronous replication. The synchronous replication is where we get our zero data loss, but asynchronous replication is a lot of times required so that we're not waiting for the round trip to occur. We're not waiting for the replication and acknowledgement from the standbys before we commit the transaction on the primary, which could slow down our application, have a huge performance hit. So there's a balance that you need to think about, and these protection modes enable that. So with maximum protection mode, it's synchronous. So every transaction that makes it into the primary will make it over to the standbys that's set up for synchronous and maximum protection, guaranteed. So then we have some more flexibility built into it, max availability. So max availability will behave like max protection. It'll try to go ahead and do synchronous replication until it hits a certain lag level, and then it will go basically drop into an asynchronous mode associated with that. However, we have some flexibility associated with it. We have the FAR-sync, which I'm going to talk about in a little bit, which provides the ability to go ahead and set up even max protection mode or max availability mode over distance with a FAR-sync instance. We also have the fast sync, which will go ahead and ensure the replication, the redo makes it over into memory on the standbys, but doesn't wait for it to commit down to disk. It can turn around that acknowledgement much faster. So we have all these different types of capabilities kind of tied with built-in thresholds, and you can go ahead and configure and tweak these. Finally, we have max performance mode. This is full asynchronous. It's 1,000 miles away. There's no way you can set up synchronous replication without having a massive performance hit to the application. So we want to go ahead and set up asynchronously. The trick, so it's not waiting for the acknowledgement at all. It's a fire and forget type of configuration where the primary will fire the redo out, the replication, and it will not wait for the acknowledgement and will simply commit the transaction. You can mix these different protection modes in the fact that you could have a local standby very close to your primary, and then you could have a remote standby. A lot of people have these configurations as part of our gold maximum availability architecture recommended blueprint configuration that you can take advantage of. But almost all these features are in DataGuard as well as Active DataGuard, with the exception of FAR-sync, which is one of our Active DataGuard features. So what is FAR-sync? What does it go ahead and provide, and how does it work? How should I use it, and what does it not make sense for? Well, the FAR-sync instance is going ahead and providing a very small, lightweight instance, just control files, log files, no database files associated. So a lot of these FAR-sync instances can be co-located at a very near distance, right? Ideally under 2 millisecond latency associated with where we replace that FAR-sync instance. Very similar to a local standby if you use that option. Now, you can't fill over to the FAR-sync instance just because there's no database files there. It's designed as a proxy that we can go ahead and do our synchronous replication to at that very close distance, and then it will handle the asynchronous replication out to one or more standbys, which makes it very interesting for a lot of other use cases like creating reader farms and so forth, and other things we might want to offset from our primary. It can also go ahead and offload encryption and transport compression as well, so it has other advantages associated with it. The one thing you need to think about with FAR-sync from a kind of a best practice standpoint is where do I place it? And it's very similar to the local standby because I need to go ahead and place it with enough isolation and enough protection that it has it. Maybe if I have a data center very close to original data center, that would be a great place to go ahead and put the FAR-sync instance. But if the FAR-sync instance is too far away, then it starts to go ahead and lose its value associated with it. So that limited distance, that latency is still critical when we think about it. And so we have a lot of recommendations. I'll point you at resource a little bit later, some best practices associated with different FAR-sync and different reference blueprints associated with FAR-sync that you can take advantage of. It has lots of different use cases that you may not even be thinking of beyond just this zero data loss protection capability. I mentioned the reader farm, and there's other ones as well that are tied with it. Now, I also brought up the fact that the whole Active DataGuard piece is not only for read-only workloads on the standbys. So we now have support for updates on the standbys as well. And that feature comes with DML redirection that we introduced in 19C. Once again, this is not an active. It's not taking the place of Golden Gate for a full bidirectional multi-master environment that you might want to set up. Instead, it's exactly what I brought it up for. It's the occasional updates or inserts that you use to go ahead and supplement your read-only workload. Imagine a reporting application, for example, that occasionally has to go ahead and do updates. Maybe it's going ahead and tracking who's reading reports. Maybe it's updating who's actually accessing what. All these types of things can be tracked. But we don't want the workload to be too high on there from an update or insert standpoint, because if you look at the diagram, the DML coming in on the standby is still redirected, as the name implies, out to the primary and makes the round trip back to the standby again. and then becomes visible to the client. This is important because we don't want assets to become compromised associated with this. But the impact of this is if you get the DML workload becomes too high on the standby, you will start to impact the performance on the standby from our testing. And I have a blog post that you can take a look at there on the MA blog that talks about this. We have some recommendations there. I will say that we've made some huge performance improvements on this with 21C. We've optimized this even more. In the blog post was for 19C. We'll be updating it for 21C. But once again, we don't want to get too high. We don't want to be too high of a percentage of the workload on the standby. It shouldn't be update or inserts from DML perspective. All right, now I'm going to talk about a very, very critical feature. This applies to both RAC and Active Data Guard. It's the application continuity feature. This is a feature of RAC and Active Data Guard. It's built into it. It's built into the Oracle database. And once again, I'm going to go back to what we talked about earlier. We want to be able to provide all these capabilities from high available and disaster recovery without forcing you to change your application. So this feature is designed to go ahead and handle your in-flight workloads. So in-flight workloads, if you did a role transition, you go ahead and one of the rack nodes die, our primary site dies, and we have to fail over to the standby. It would go ahead from a committed standpoint. All the committed transactions are taken care of, and they have been for quite some time. But the in-flight transactions would normally fail back to the application. The application would have to deal with it, or in a worst case, it would actually show up as errors for the end user. They would be impacted directly. Obviously, we don't want that to happen. Instead of a blackout situation for those in-flight transactions, we'd much rather it be a brownout. Application continuity takes care of that, right? And from both a planned maintenance standpoint, they can go ahead and drain sessions out and do it very cleanly as you're going ahead and rolling through, let's say, rolling patching with RAC, or in the case of disaster recovery, if we're jumping over to Active Data Guard, and it will automatically replay those transactions. Notice this is not just something that we have for Java. We have it for all the different major language platforms out there, Python, .NET, even Node.js, PHP. With all these different technologies, we can go ahead and do it. And it's just a driver in basically the connection string that you have to be sure are correct, along with being on the correct version of the Oracle database, which should be 19C or higher, to take advantage of this functionality. And we even improved it with 19C. We added transparent application continuity, which doesn't even require connection pooling. Now, there's a ton of different literature on this, a checklist that's provided on the application continuity website to have you take advantage of it. People have been asking for the functionality forever. You know, how can I go ahead and not impact my application during a role transition? Application continuity is the missing link. It provides that functionality, allows you to go ahead and do that. So, uninterrupted, right? Application connectivity, everything's going to go ahead and replay on the standby or the other rack node associated with it. It's basically going to be a small performance hit from the application perspective, from the application client, but it'll go ahead and it'll replay the request, automatically returning it back to the application, and thus the application transaction, and hopefully the end user completes the actual transaction associated with it in the case of an interruption. And once again, it also has session draining built into it for planned maintenance purposes. All right, I threw this slide out there, the very noisy slide associated with Active Data Guard. And I'm going to jump into some 21C features here in a moment, as well as go ahead and kind of highlight how they're critical to the application. I'm not going to go through everything because the investment, Data Guard and Active Data Guard are one of the most invested technologies within the Oracle database. And you can see this here. We're going ahead and rolling it out. And these are just features that are built into the core Data Guard and Active Data Guard feature in the core database. We also have gone ahead and we've added tons of automation on our cloud as well, from Autonomous Data Guard to everything we've gone ahead and put in with XSCS and XSCC, our cloud at customer, associated with Data Guard. So this is a very, very core feature, a very important feature, and we have a large team that's going ahead and working on it continuously to go ahead and provide all the capabilities. Now, I'm quite proud with 21C. We delivered on a lot of features that we've been wanting to go ahead and provide for some time now, and I wanted to go ahead and kind of jump into those. One of the features that we brought in was in 19C, we had a database buffer cache was preserved. Now, one of the problems that people had was with the standby, when they had their read-only workload going ahead and running on active DataGuard instance, when a role transition occurred, it would blow away all those caches, impacting the performance of all the read-only workload. Basically, any type of reporting application or any workload that's running on the standby would be impacted by those caches being blown away. So one of those was a database buffer cache. The other one was the result cache. Database buffer cache, we went ahead and resolved that with 19C. We preserve it now on a standby instance. Same thing on the result cache now with 21C. We protect it. The whole goal is to protect the performance of your standbys when a role transition is happening. It's already going ahead and getting all the read-write workload. So the workload's already growing quite a bit associated with it. We don't really want to blow away the caches as well and really impact those applications. And that's what this feature addresses. Now, another thing, I mentioned the DataGuard broker being critical, and everybody should really be utilizing it. One of the complaints that we got, though, was, well, it was very hard to go ahead and maintain the directory structure that we had. It seemed like a simple thing, but the directory structure was somewhat confusing the way we had it laid out. So now what we've gone ahead and done, we've introduced a new environment variable that you can go ahead and configure, DG_admin, and we have subfolders very, very cleanly with configuration files, the log files. We have callouts associated with this, so callouts are supported now as well, and everything is consistent and standardized associated with this. Very easy to go ahead and configure, set up, track, and of course export if you desire to. Now, I mentioned the DataGuard broker can go ahead and handle the deployment of going ahead and setting up your DataGuard configurations. Now it can also go ahead and configure and deploy FARSync instances as well to go ahead and set those up. So it can easily go ahead, it was already configuring them from a standpoint, but you had to deploy them manually before, and now we handle the creation, which automatically goes ahead and set up the configuration as well as part of it. So with 21C. Now, we've built a lot of validation. So two of the things that we've done here with DataGuard over time is we focused on validation and making sure that things are very easy to go and validate, and we've added more knobs. And fast start failover is one of those features that, once again, if you want to get down to zero downtime or close to zero downtime with your failover, then fast start failover is critical with it. It's part of DataGuard, so it's part of the core feature. And what it does is automatically going to go ahead and fail over if any issue is detected from either a standalone observer, which is a small little component that can be deployed independently, or from the actual standby instances. If either of those can detect the primary and see that it's up and running, then fast start failover will not occur. However, if neither can detect it, if our observer can't detect the primary and neither can the standbys, then a failover will occur. And we have a ton of different configuration properties associated with this to simplify it and ensure you don't get false failover events occurring associated with this. The other piece that we've done is we validated it. So validation is built into it, and we validate the configuration of fast start failover. We also go ahead and validate the actual callouts associated with it. So you can go ahead and you can have pre and post callout scripts that are part of your fast start failover now. We also validate those files are available so you can be sure they're up and running. We also have a couple other features like observer mode and so forth that allow you to go ahead and test fast start failover without actually going ahead and failing over the instance. And this is all in the theme of validation and adding more knobs to fast start failover in DataGuard as a whole, giving you more flexibility. So those callouts that I mentioned, they're validated as part of it. It seems like a very, very simple feature that people have been wanting as part of it to go ahead and tie in. If they need to call anything at the application tier before or after a failover occurs, they now can go ahead and do that with fast start failover. And of course, all of this is validated as part of it. And this validation is reducing the overall human errors that might occur associated with this as well. Lag allowance, once again, another knob, this time associated with max availability mode. How much lag will we go ahead and allow to allow a fast start failover before we require you to go ahead and do a manual switchover instead? Because if the lag is too high between your primary and your standbys, you may not want that fast start failover to occur. Now, obviously, in maximum protection mode, it's your synchronous replication. So you're guaranteeing that everything's over in your standby environments as well. But starting with max availability mode, that's not the case, because they can go ahead and switch over to asynchronous replication. Now, how much lag do we want to go ahead and be there, be present? How high can it get before we prevent the fast start failover from occurring? So this is one of those features that were added specifically, so we expanded it into max availability mode as well, at high demand from people that want to go ahead and take advantage of this functionality. And we've been pushing fast start failover out there because people really want that low RTO, that low, very, very low downtime, ideally very close to zero. And fast start failover is really the only way to get that. The second you put somebody in the seat that has to push the button and go ahead and enable the switch over, first of all, they might second guess that. They may decide they're not sure whether they want to do it or not, resulting in more downtime. But the other part is somebody just simply having to hit the button is going to add probably minutes onto your failover, even if they're very quick about it. Now, I have to speed things up a little bit here as far as the overall presentation. I want to leave some time for Q&A at the very end. But I want to bring up a very critical feature that we have in 21C. And as most of you know, when you configure active data guard or data guard in a multi-tenant environment, it's done at the container level. It's done at the CDB level. So all the different PDBs, you can't fail over a single PDB. You fail over all the PDBs within there. Now, this makes things very easy to configure. It has all the features of active data guard in it. We support all the features associated with it to provide that level of protection. But you can't fail over a single PDB associated with it. So you get all that protection, and you only have to configure it one time for all the PDBs. Very, very useful, particularly in a converged database environments where you may have a bunch of different workloads running in PDBs. Being able to configure this once is very, very, very ideal. And I think for the majority of customers, this is still what everybody's going to want, is the CDB level configuration. But we did get people that want to fail over a single PDB. Maybe it was in bad health and just one PDB was failing over. Maybe it was a choice of switching over, but maybe I don't always want to fail over the entire container. I may also want these containers, some of these containers, the PDBs within them, some of them may be primary and some of them may be standby, which means both CDBs would be primary at the end of the day, and the PDBs within it, we may want those to be either a standby role or be in a primary role. So with 21C, we introduced a feature we call DGPD'evolves for short. But basically what it is data guard at the PDB level. Now you have to choose. You have to choose whether you want it at CDB or you want it at the PDB level to go ahead and set this up. But what it provides is the ability to go ahead and address all those different use cases that I mentioned. If I want to fail over just a single PDB, if I want to go ahead and have, you can see we're mixing and matching here of these containers, which one's the primary and which ones are our secondary standby environments, making both the CDBs primary and just the PDBs either in the primary role or in the standby role. And we can mix and match the way this works, right? And we can even have unprotected PDBs if we desire to. Maybe from a consolidation standpoint, some of the PDBs are test mode, right? As far as you're going and setting up or be used for other purposes that don't require protection. So you have all the flexibility built into here. But it does come a little bit as a price, so some of the features are still rolling out. So CDB, we have everything, right? All the features we have, essentially, you can go ahead, it integrates with RMAN, we have all the protection modes supported, fast start failover, DML redirect, the rolling, DBMS rolling, app continuity, all those features associated with it. Now, with DGPDB, this is the first, we're going ahead and releasing it right now, and it's in the process, by the way, it's rolling out in the 21C timeframe. It's not there today if you download 21.4. It will be there very soon. It's something we intend to roll out as part of the 21C release. But when it rolls out, it will have a lot of limitations associated with it, which we will be addressing over time. And we prioritized all these, a lot of the active data guard features, for example, real-time query offloading, automatic block repair, DML redirect, the app continuity features. All those features, the integration with RMAN are all something we're working on support. So you can go ahead and take advantage of the feature. And we'll be going ahead and rolling these out. We'll be rolling out the additional features in subsequent releases. It will evolve over time. Our intent is to get all the ADG features in there so it's available whether you choose CDB or PDB. But this is something very important, and you guys should go ahead and review this. As we're rolling out documentation and so forth, you can review this feature. But this will be a useful slide for those that are going ahead and considering the trade-offs associated with CDB versus PDB, not just from the standpoint of the container, but from a feature standpoint. All right, So just to go ahead and wrap things up, the key takeaways from this presentation are the Converged database. Will we go ahead and deliver all these different features, all these different paradigms, and all the infrastructure, security, planned maintenance, high availability, disaster recovery, security. And the Converged database is all going ahead and built in. It's all administrated the same way. It's all consistent, regardless of workloads or workload data types associated with it, while still supporting all of these. We still get the isolation that we want because of our multi-tenant capability that's built in by default into 21C. And as you go ahead and upgrade, by the way, to 19C, now's the time to go ahead and pick up multi-tenant. Multi-tenant for the first 3 PDBs is built in. You don't need the multi-tenant option, and you should take advantage of it. Get it set up, do it part of the 19C. If you haven't already upgraded 19C, it's a great time to go ahead and set up your multi-tenant configuration as part of it. As 21C onwards, it'll always be there by default. Now, Oracle RAC provides our local high availability and scalability associated with that, built in, it's part of the Oracle database. Take advantage of it, and it's evolved quite a bit up to where it's at with 21C with our new generation RAC, all the capabilities that Anil talked about. Data Guard and Active Data Guard. So Data Guards are kind of our core capability. You get it with Oracle Database Enterprise Edition to take advantage of it from a disaster recovery standpoint. It's how we set up our standby, it's how we protect our database over long distances and provide full disaster recovery. And Active Data Guard provides more advanced protection like application continuity and automatic block repair on top of what Data Guard provides, as well as a lot of other features associated with kind of offload. We're calling that active ability to make your standbys active. And application continuity is a feature of both RAC and Active Data Guard, which protects your in-flight transactions. Everybody on 19C or higher that's using RAC or Active Data Guard should be using application continuity. If you're not getting the full value from those capabilities. And it's a very, very, very powerful piece of technology that will turn blackouts from the application perspective into brownouts. You just get a small performance hit during a role transition, and then your in-flight transactions will replay on another node instance or on a standby database. Tons of different resources out there. I mentioned a few of these already. First of all, we have the series. We have the series from last year where we go through all these technologies. You can find them on YouTube. You can go ahead and log in. And this series that we're running right now, we did the Converged database, we did multi-tenant, a couple other topics already. This link, we're going to send a PDF file out, by the way, so you guys can all click on these. You'll find them out there. And some of them are on demand, but they'll eventually move to YouTube as well. But that entire MA webcast series is on YouTube. It's available. You can watch and learn about all these different technologies. And then, of course, all the O.com product pages, so RAC Pay, Active Data Guard, app continuity pages, as well as maximum availability you can check out. We've also reworked all the different best practices associated with it, especially with Active Data Guard and Data Guard specifically. We've gone ahead and moved from a lot of those papers, those individual papers that you had to dig through to try to find. We've moved them into documentation, and they're all up there off the MAA. So all the best practices associated with app continuity, Active Data Guard, Golden Gate. We're rolling out RAC right now. We're going and expanding that all the time. You'll see other technologies like EBR and SiteGuard. I will be going ahead and rolling into that. And then we have some papers that have been recently updated with Data Guard, Active Data Guard versus storage remote mirroring, the differences there, and why storage remote mirroring is slightly dangerous with the database because you can replicate anything over from the disk. But all these are at your disposal. And if you want to get hands-on with this, what's the next step? You can go ahead and take a look at our live labs. So search for Oracle Live Labs. You'll find tons of stuff up there. We have a high availability category where you can go ahead and kick the tires of Active Data and get hands-on with the technology. It'll spin up resources in our cloud. You can use your own tenants, or we can go ahead and spin some up for you so you can take advantage of them and you can test them out. And then, of course, check us out on Twitter and LinkedIn. Take advantage of our Oracle Cloud free tier, and you can take advantage of the always free or the 30-day free trial to go ahead and test these, tie them in with your live labs, run some applications on top of them, whatever you desire. Go ahead and kick the tires. And the multi-tenant, many other hands-on labs are out there as well associated with it.